Hello everyone and welcome to a new discussion which we are going to have on springs in India, and this is in two parts. So, part 1 we are going to have, and before this we have also discussed what is springs, different types of springs, spring shed and watershed, and their differentiation and so on. As you know that in India we are having thousands of springs since very long time. This is one of the examples of springs which was, of course, the painting is there, but it is from Rajagiri in Bihar, currently in Bihar, and this is a hot springs which is there. So, if you start looking the history of springs in India, one of the examples this comes like this. So, for many people springs are the sole source of water, but here this is a hot water springs, there is a sulfur content and other minerals, so people go and take bath. Anyway, so overall from springs of India, the 29% of water in Ganga is from glaciers till the river reaches Muradabad, UP, and the rest comes from springs. And you can think that what is the contribution of springs? Only 29%. That means that 2/3 of water which is coming in the Ganga river is coming from either springs or rain. So, these glaciers, snow melt, ice melt, which is glaciers 30% and rest is coming from springs. Springs are a big contributor of water in the Ganga, and you know it is one of the largest river in the country, perennial river, covers a very large part of India through Indo-Gangetic plain and so on. So, springs plays very important role even towards the maintaining or sustainability of the Ganga. So, spring discharge is reported to be declining due to increased water demand, land use change, ecological degradation and climate change. But apart from climate change, the other major reason of changing of water supply from springs or spring discharge is human interventions. And of course, natural calamities like landslides or maybe earthquakes, they also change, as we have also discussed in the previous section. The human interventions, like a lot of development activities are taking place in Himalaya or in other hilly terrains of India, and they are changing the spring locations and discharge also. So, this decline might be because of many reasons just narrated here, but other human interventions is one of the important thing. So, as we have been discussing in earlier discussion, that by some means if we can increase the spring recharge or manage better watershed management or do watershed management, then this scenario, the declining issue will not be there. So, it is manageable, it can be managed. This is one of the figure which is shows very important, that the quantity of water is getting reduced through the overall springs in the years with time. So, about 50% of the springs have dried up or turned seasonal. This is a rough estimate about the conditions of springs in India. If you go in Himalayan terrain, particularly like in Garhwal Himalaya, you would find lot of villages which were had the perennial springs or water supply, drinking water supply, and even that water is going for their agriculture land, terrace farming, is no more those springs are there, they have dried up. Because in upstream or in higher levels some human interventions have taken place, or because of reduced rainfall, removal of forest and many other factors, and these are all causing the reduction. So, if the springs were here, now if I take this, then 50% of the springs have reduced. Now, there are even today there are about, this is just again a rough estimate, because today if you do the survey and after 2 years you go, some springs may disappear and some new springs may also appear depending on what tectonic activity or human interventions have taken place. It is not all necessary that all the time human interventions are removing or reducing the number of springs. A spring may get disturbed, may appear somewhere. So, that is, so overall there are 5 million springs across India, which you can see on the right figure. The major ones are located in Himalayan terrain, many are in the central India and some are other places also, in the Deccan Trap also, like west coast continental margin in that part also, and northwest southeast Himalaya you can see, and Narmada Son Tapti lineaments. Like Narmada river is a perennial river and there are no glaciers, no ice, nothing. So, that means the water is coming through the springs. Same with the Chambal river in the central India and many other rivers in hard rock terrain of India. So, 5 million springs across India, out of which nearly 3 millions are in Indian Himalayan region. So, large part of springs are located in Himalaya. In case of Ganga, we have said that only 1/3 is being contributed through glaciers or maybe little more by the ice. If we go for this Nilgiris areas or western Ghat, eastern Ghats, Himalaya, springs are a safe source of drinking water for rural and urban communities. The springs generally do not have polluted water and they are having some minerals which are dissolved in it, which are good for the health also. I gave the example of, like in Europe you go and they are selling spring water at a high cost than simple processed water. So, it carries a very important minerals which are good for humans. So, many springs are sole source of water. In many places that is the main source of drinking water, especially in hilly terrains. This part we have already discussed that 29% of the water in Ganga is coming from this glaciers, rest is coming from springs. Spring discharge is reported to be declined due to increased water demand, land use change, ecology and other things. Climate change and rising temperature, these are the things which we are facing and they maybe this another phenomena which we are observing is rise in rainfall intensity. That means the time available for recharge is getting reduced. Though the total amount of water might be the same per year per area, but the time or number of rainy days are reduced and therefore, there is a reduction in the recharge. Also there is a reduction in its temporal spread, that means time has reduced and marked decline in winter rain and problem of dying springs is increasingly felt across Indian Himalayan region. So, many villages are becoming ghost villages because there is no water available. Now, only way we can bring water to those villages which are settled on top of mountain range or slopes is to pump out water from a river and for a few hundred meters, then the water can be supplied, but that would be limited. Instead, a perennial spring for a village is much more or much better. So, as we know that any change in spring hydrology in water set or spring set has clear ramification on river hydrology. So, rivers are, if springs are getting dried, then river hydrology, the surface water hydrology will also get dried. Whether in the headwater regions or where the springs manifest themselves as source of rivers. So, there are many rivers which are originating from springs and in the lower reach plains of river systems where they contribute almost invisible as base flows to the river channel. So, many times it is very difficult to know from where the water is coming in a river. So, we are basically having a invisible source of flow which is contributing the rivers. If I give the example of Narmada which originates from Amarkantak, that is the origin is spring and then it is remain perennial, it is a good source of water in the central part of India. So, if we see the spring as indispensable resource and the distribution of springs in India, the numbers all are given here. The large part of springs as we have seen from Himalayan region, see the large part is Himachal, Uttarakhand, these are the two major, another one from northeast India and some other Sikkim and other things are also there. So, this is the distribution of springs in Himalayan region. Now, springs are fed by aquifers that we know, a system of rock or rock material which stores and transmit water. So, it is simply a aquifer which is the groundwater surface is cut because of topography, and that forms the springs. So, therefore, the occurrence and movement of groundwater in aquifer is based upon the storativity and transmissivity of aquifers. Here what we are getting water on the surface without any drilling or creating a bore well because of change in topography. So, but the other condition will remain same. So, the occurrence and movement of groundwater will depend as storability and transmissibility of aquifers. And extent of Himalayan aquifers, their geometry and hydrological parameters exhibits large variation as a function of complex geology of the Himalaya. Earlier I said in the previous discussion that each spring or each spring shed is unique, each watershed is unique. There are large variations in all these setups, and geology of each spring shed is also different, and therefore each is unique. And if we want that a particular spring should give a constant water supply, then we must understand the entire geological setup of that area, and accordingly the watershed management, then only we will have perennial source of water from that spring and constant discharge. But we know that Himalaya is having a completely a very complex nature of aquifers, and which is resulted in a diverse spring hydrology, typology and types of springs and spring water properties, whereas it is spring discharge or spring water quality. Quality also matters sometimes, though most of the time the spring water is drinkable, but in some cases might not be possible when high dissolution of minerals are present there. So, revival of springs, restoration of springs, which we have also discussed earlier, based on a classical approach using watershed management, and also spring source protection. Spring source protection means the recharge area from where the recharge is happening. If we protect that area by having forest or by not allowing any human interventions and so on, then we will have perennial springs. So, what is approach needed? The revision keeping in mind not only the complex geology of the region, but the diverse system of rock types and structure even at seemingly a local scale. Each will have unique setup, and therefore, for each spring shed the geology or the geological setup has to be understood. So, the relationship between watershed, aquifers and springs is important, and designing and planning of conserving spring water or spring shed, which is again important. Few examples of here, this institute is well known for such a kind of work, which is on in the identification of springs, spring management and monitoring of springs are also there. So, few examples from their site I have just got it here, a screenshot. As you can see that these some are the very open springs, as you can see the water is coming out from the surface, but some springs are inside. So, they have constructed some permanent structures, so that these springs remain for long time and no harm should occur. And you know that this IHR Indian Himalayan region and different districts are shown here, and this web page portal, if you go on any of the states, then it will let you know what are the details of individual springs which are found here. So, very good source to know about springs, and this is inventorization of springs for entire Indian Himalayan region is there, which is excluding basically Nepal. If I talk about springs of Uttarakhand, then you can see that the large number of springs are located in Kumaon Himalaya rather than Garhwal Himalaya. So, the outward migration of humans from Garhwal Himalaya is much more because of reducing water supply or reducing springs, whereas this part of Kumaon Himalaya is having a better geological better vegetation cover, and more springs are there, and outward migration is also less. So, you see that the importance of springs. because a source of water has to be there for the sustainability of life in the hilly region, not only for humans, but for animals as well as for crops. And of course, the higher Himalayan regions are having glaciers and other things, but springs are in the lower reach, but in the Kumaon Himalaya you are having more, in Garhwal Himalaya you are having less. And the geothermal springs are also having varied temperature and chemical conditions, which we will also discuss. So, now geothermal provinces in India, they are the almost same as the spring provinces of India. So, many such provinces are having hot springs. Major geothermal spots are also shown here, where they are there, except one or two places. There is a generation of some power through getting steam out of these thermal springs, and power is generation, but otherwise sufficient temperature or vapors are not available that can put the which can run the turbine. So, lot of such springs are there. Many religious places are also located near such thermal springs like Rajagiri. I gave the example of Bihar, but in Himalaya like in Kedarnath and other places, where from where you start climbing like Gaurikund, you are having hot springs. Many places, and there are some other areas where you are having again springs in this Deccan Trap area also, and this is Gulf of Cambridge. So, geothermal province in India, this part is also having springs which are getting good water, water which is having high temperature. So, springs release huge amount of carbon dioxide in the atmosphere, and that is from carbon dioxide point of view, that is a concern also. So, Himalayan host about 600 geothermal springs, which needs to be considered while estimating emissions to the carbon cycle and thereby to global warming. So, we are getting hot springs, but the problem about the carbon dioxide. So, lot of interrelated issues are there, and which may create problems in future also. One of the very good example of a very hot water which comes out in Himachal Pradesh, the place is called Manikaran. There is a big Sikh shrine is also there, and the rice and lentils which is supplied in the langar is cooked in that water. So, that is a very good use directly in a religious place of hot water. So, now we are coming at the end of this thermal spring discussions, where this the other important part in the last we have discussed is the carbon dioxide. So, from where this carbon dioxide is coming, some discussion we will have, that this carbon outflux from the earth surface or earth interior to the exosphere or coming out of earth is through volcanic eruptions, fault zones and geothermal systems. So, geothermal systems are basically our hot springs contribute to the global carbon cycle that affects short and long term climate of the earth. So, these are also disturbing the carbon dioxide which is coming through this thermal provinces are also disturbing our climate of the earth. This carbon dioxide in thermal springs are sourced from metamorphic decarbonation of carbonate rocks present deep in the Himalaya core along with the magnetism and oxidation of graphite. So, lot of processes, geological processes underneath the surface of the earth are happening, and they are generating carbon dioxide. And most of, as you know, that geothermal water is dominated by evaporation followed by weathering of silicate rocks. Evaporation, vapors will come out. I gave the example of Manikaran. At many places, I would say hundreds of places in the small area, you will see the vapors are coming out from the surface of the earth. And this vaporization basically followed by weathering of silicate rocks. So, whatever the rocks are there, they are getting weathered, and of course, wherever the water is coming, it is really hot near the boiling point, and that is why food is cooked there. Now, isotopes are being used to delineate the spring set. Similarly, isotopic analysis of different kind and that further points towards a meteoric source of geothermal springs. So, what is the source of such springs? It is coming through identification of isotope analysis is meteoric source. So, there are various sources from where the carbon dioxide is coming and getting mixed with the atmosphere and might be contributing in long term the change in the climate of the earth. So, with this I thank you all the best.